for the limitations of the water Raoult's law, it is there. So once I'm going for limitations of Raoult's law, it is applicable only for dilute solutions. It is applicable only for the dilute solutions. It is applicable only for ideal solutions. It is applicable only for the ideal solutions. From these 2 points, you might have got hint. From these 2 points, you might have got hint. What you might have got hint? Dilute solutions are nothing but ideal solutions. Correct now? It is applicable only for dilute solutions. It is applicable only for ideal solutions. Means dilute solutions are nothing but ideal solutions. Dilute solutions are nothing but what ideal solutions are there. Dilute solutions are nothing but ideal solutions. Now coming for point number C. It is this point already have given stress. It is applicable. It is applicable for non-volatile solute. It is applicable for non-electrolytic solute. It is applicable for non-volatile solute and non-electrolytic solute. For non-electrolytic, already I have taught you on that day while explaining the concept. Non-electrolytic means neither associate,
not ionization.
Dissociation. So whatever the solutes are there which neither undergoes association nor undergoes what? Dissociation. Neither undergoes association nor undergoes dissociation. They are called as an non-electrolytic solute. It is there. So this is the limitations of the what Raoult's law. It is there. While explaining the concept last week, this each and every point I have given to you. I have not dictated you, but orally I have taught you. Done?
Yes, sir.
Now I'll go for the last point in this. Last point in this, I'll go for a last point in this. Sometime in the examination, the graph comes, and therefore deliberately I'll show you comparative. Deliberately I'll show you comparative. Now this is the last point. Already I have taught you Henry's law. Already I have taught you Henry's law. In the Henry's law, what I have mentioned to you, partial pressure of a gas is directly proportional to partial pressure of a gas is directly proportional to the mole fraction of a gas. On removing this proportionality, we are getting here as a what KH, and then I have shown you when we are drawing the graph between the pressure of the gas and the mole fraction of the gas. On that day, clearly I have mentioned to you it is Y is equal to nothing but mx. It is there. So from this, it's very clear that C is not there. C is not there means intercept, it is not there. It is the straight line graph starting from the water origin, it is there. And yes, this is the straight line graph starting from the water origin, it is there. Now I'll go for the Raoult's law. Raoult's law I have taught you last week. Raoult's law I have taught you last week. And in this Raoult's law, what I have given to you, pressure of a solution. You say pressure of a solution, or for your understanding, vapor pressure of a solution is equal to P naught. Is equal to P naught. And this is nothing but it is a mole fraction of the solvent. It is there. Can I say mole fraction of a solvent?
Yes, sir.
Yes, because whatever this Raoult's law I have taught you, clearly I have taught you in that Raoult's law, solute is a non-volatile and solvent is volatile. Strictly speaking, if you remember last week, I have clearly mentioned to you mole fraction of a volatile component. Check it, the notes, whatever given to you. I have clearly mentioned mole fraction of a volatile component. Check properly.
Yes, sir.
Yes, and on that day, clearly, hey, whatever I'm writing on the blackboard, you should write in the cash book only or here and there. Otherwise, before examination, notes is not there, paper is not there, books we have not marked, nothing we are knowing. Again, back to square. Again, back to square. The back to square condition, it is not there. And on that day, maybe probably last Thursday or the last Friday, I have mentioned that in a cash book and in the NCRT book, they have given solvent, but strictly speaking, it is a mole fraction of a volatile component. Volatile component may be solute, volatile component may be solvent, or maybe both it is there. So if the graph is plotted, if the graph is plotted, and here I have mentioned to you slope is equal to kh. Slope is equal to what? Kh, it is there. So if here I go for the vapor pressure of the solution, and here I'll go for the mole fraction of the solvent. Solvent is nothing but our volatile component, it is there. Then if here I am making a straight line, same graph, check exactly, means exactly same graph, it is there. Whatever this value, this place it is there, it is called as a P naught, it is there. So Henry's law graph and the Raoult's law graph, both are same or different? Exactly same. Exactly means exactly same, it is there. Make it.
Done, sir.
So whatever topic I am teaching you, just write in the Akash book only any point typical you are observing. No, sir, this graph also given in the Akash book. This is also given in the Akash book. Therefore, we are not copying, agreed. But in the Akash, they have not given the same place. Unless until not given the same place, you can't go for comparison. As a human being, you won't turn 2 or 3 pages and say, human nature is there. Human being wants everything spoon fed only. Spoon fed only. Should they up this one?
Yes, sir.
Yes, sir.
Now I go for the new side heading. So last side heading probably on the last Tuesday or Wednesday. Last Tuesday or Wednesday, I have taught you solution of solid in liquid. Solution of solid in liquid. And now I'll go for the another side heading, solution of a new side heading. Number I am not knowing, 9th or 10th, whatever number it is there. Solution of liquid in liquid. Solution of liquid in liquid. And now here I am clearly mentioning that this liquid is volatile. This liquid is also volatile. Hey, so from this, it's very clear that both the solute and the solvent is volatile. Liquid in liquid. So if this is solute, this is the solvent, it is there. And clearly I'm mentioning both solute and the solvent is what? Volatile, it is there. If both solute and the solvent is volatile, now for understanding this, always, whenever I'm going for this one, hashtag it is nothing but maybe understanding point or maybe highly informative point. And now I'll go for the same condition, same condition. It is a closed vessel, it is there, closed vessel at given temperature, because if vessel will be closed, then only vapor pressure we will have. If vessel is open, vapor pressure will be negligible. Why? Because all the vapors will escape. All the vapors will escape. Why escape? Because only evaporation will be only there. Condensation won't be there. Condensation comes in picture. Condensation comes in picture when the vessel is what closed. It is there. In the open vessel, condensation is occurring. I'm not saying it is zero, but that condensation is negligible. That condensation is what negligible. It is there. And now here I'm having the liquid. Deliberately, I have drawn two types of condition: a small line, big line, small, big line, small line, big line, small line, and then big lines I have gone for, just to show you two different types of the liquids are there, but both are volatile in nature. Both are volatile in nature. When both are volatile in nature, here vapor accumulated will be more or high? High. Vapor accumulated will be high, and contribution of both
Solute and solvent.
that's correct. Contribution of both solute and the solvent is there. So here in the previous example, whatever I have taught you, solid in the liquid, there I have taught you whatever here vapor is accumulated, it was only because of the solvent, and solvent was liquid because it is volatile. But in this case, I am assuming both are liquid and the liquid it is there, and therefore here large amount of the vapor is accumulated, and here contribution is for the both liquid. Out of both liquid, one is behaving as a solute, one is behaving as a solvent. Anyone doubt here?
No, sir.
No, sir.
Copy this one.
Done, sir.
Done. Very good. Closed vessel at given temperature. Because vapor pressure depends upon temperature, na beta. So therefore, you have to specify temperature. Closed vessel at given temperature. Good. Now, still I am not going in detail. Still I am going for the understanding point only. So what is the Raoult's law we have read? Raoult's law we have read that vapor pressure is equal to P naught into mole fraction of the volatile component. Can I say? Can I say?
Yes.
Vapor pressure of the solution. Only for your understanding here, I am writing Vt as a vapor pressure, and this is nothing but Raoult's law. This is nothing but Raoult's law. It is that Raoult's law. It is that. Now I'll go for the let let solution contains two volatile liquids A and B, because what is our topic? Our topic is liquid and the liquid, and clearly beforehand only I have mentioned both liquids are volatile in nature. So therefore, again and again, question should not be asked, sir, it is volatile in nature or not. Yes, it is pakka. Both are the what? Volatile in nature. That solution contains two volatile liquids, what? A and B, it is there. So now I'll go in this way. Vapor pressure of the A is equal to P naught of A into XA. Can I write?
Yes, sir.
Then I will write vapor pressure of the B is same, exactly same thing. P naught of the B into XB. Mole fraction of volatile component here. Both A and B are the what? Volatile component. So now I will write in this way. Vapor pressure of the solution is equal to vapor pressure of A plus vapor pressure of B. Can I write?
Yes.
Yes, sir.
So I will write this as in vapor pressure of the solution is equal to vapor pressure of the A and B. And now I will write in the proper way T. T means total vapor pressure. Total vapor pressure is equal to T means total vapor pressure is equal to P naught AXA. On the place of this, I am writing P naught AXA. On the place of this, I am writing P naught XB. And this is our very, very good formula to solve the questions. Very, very good formula to solve the question. And this formula is applicable based upon which law? It is applicable based upon the what? Raoults law. It is there. So this is also Raoults law formula. This formula, whatever the formula I have applied day before, yesterday or now or 1 week back, there I have assumed only solvent is volatile. Now I am assuming both the solute and the solvent is volatile. When both solute and the solvent is the volatile, then this is the way to calculate the question. What is PT? Total pressure. XA and the XB are the what? Mole fraction of the A and B. What is XA and the XB? PT. Total vapor pressure of solution. What is XA and XB? XA and XB is a mole fraction of component A and B in liquid. Very, very careful. Mole fraction of component A and B in liquid. So XA and XB is a mole fraction of component A and B in the water. Liquid, it is there. P naught A and P naught B. What is P naught A? P naught A is vapor pressure of A in pure state. Vapor pressure of A in a pure state. What is the meaning of pure state? Only A component is only there, B is not there. And this is nothing but vapor pressure of the B in pure state. So P naught A and P naught B is the vapor pressure of the A in the pure state and vapor pressure of B in the pure state. Make it. PT is a total vapor pressure of solution. XA and XB is the mole fraction of component A and B in liquid. P naught A and P naught B is vapor pressure of A and B in pure state.
That's all.
Oh, very good. Good. Now, if you are having a doubt, what is this VPA and the VPB? VPA is nothing but partial pressure of A. VPB is nothing but partial pressure of B. Partial pressure of B. Once I am writing partial pressure of A and the partial pressure of B, once I am writing partial pressure of A and the partial pressure of B, now you are having a very clear idea according to Dalton's law of the partial pressure. Total pressure is the sum of the partial pressure of the components. Can I say?
Yes.
Yes. So PT is nothing but our total pressure, and this is nothing but our PA, and this is nothing but our PB. It is there. This is PT. This is nothing. Whatever this it is there, this you can call as a PA also, and this you can call as a PB also. So vapor pressure of A means partial pressure of A, vapor pressure of B means partial pressure of B, and vapor pressure of solution is nothing but PT. Make this also so that in the future you won't have any doubt. So just here before you write PA, here before write PB, and here write PT, so that confusion won't be there for you. So you write VPA or VPB, you write PA and the PB, you write in this form or this form, meaning is same partial pressure of A and partial pressure of B. Hey, till now I am not at all going for the main topic. Till now I am going only for understanding part only for understanding part. Because if straight away I'll go for the main topic, everywhere you will get confusion from where this is coming, how it is coming, and you'll mug up. Mugging is not good. Mugging is not at all good. Mugging, you can mug your name, you can mug my name, that's all, but otherwise, everything you can't mug. Once copied, let me know.
Done.
Okay.
Yeah.
Hey, again, don't write just whatever I have given here. Just before this, write PA, before this, write PB, and here write PT. Again, don't copy everything.
Done, sir.
All official rub it.
Yes, sir.
So main side heading is a solution of liquid in liquid, but still in that I am giving you explanation part only. Only I am giving you explanation part only. Main topic, if this you will understand, main topic will become very easy. Very easy. Now coming for the another understanding part. Another understanding part is calculation of composition. Star mark. Questions, neat questions are there. These are not the questions of IB level. They are neat level questions are there. At the back of the book, 16 or 17 questions are there based upon this concept. 16 to 17 questions based upon this concept. And yes, in the local examination, not this Sunday, coming Sunday having examination, there you will get this type of questions. So calculation of composition in vapor phase. calculation of composition in the water vapor phase. It is there. No question arises. What is this vapor phase, sir? Just understand. Small diagram I'll draw. Understanding. Condition is same. Closed vessel at given temperature. This condition is must. And here we are having two liquids A and B. Again and again, I won't say both the liquids are volatile. Both the liquids are volatile. It is there. And here we are having vapor is accumulated. And just 5 minutes back, I have told you this vapor is contributed by both components A and B. This is the same diagram which I have given to you earlier. Now let us go for what is the meaning of composition of vapor phase. Let, assumption I am going for, let XA and XB is the mole fraction of component in liquid state. In the liquid state, YA and YB is the, you won't write in this way, write in the proper way, is the mole fraction of component in vapor state. This is the calculation of composition in the water vapor phase. Calculation of composition in vapor phase means what is the mole fraction of A and B is A and B are the two components. These two components are there in the liquid state also. They are there in contributed by both A and B. It is there in the vapor phase also. So question is asked, what is the amount of A present in the vapor? What is the amount of P present in the vapor? This is the topic, composition of component in the what vapor phase it is there. So if this we are assuming as an XA and the XB, long back I have taught you, actually it is called Chi, but rather than calling as a Chi in the normal language, we will call as an X. So if we are going for assuming XA and the XB is the mole fraction of components in liquid state, so therefore we are going for YA and YB is the mole fraction of the components in the water vapor state. It is there. If you have copied this one, tell me, I'll go for the continuation. So this you are not forgetting now throughout all the books, Indian books or international books. YA and YB is the mole fraction of component in vapor phase. XA and XB in the liquid phase. This is called liquid phase. This is called as a vapor phase.
Done.
Completed, sir.
Okay. Now I'll take concept of both first year and second year. Concept of both first year and second year. Now first I'll go for second year. According to Raoults law. According to Raoults law. Because just now we have read Raoults law. PA means vapor pressure, partial pressure of A or vapor pressure of A. Can I write is equal to P naught A XA? Can I write?
Yes.
And if I am going for a vapor pressure of the B or the partial pressure of B, can I write?
Yes.
Now I'll go for first year. according to Dalton's law. According to Dalton's law. If you have forgotten, then partial pressure of the ith component is equal to number of moles of ith component by total number of moles into total pressure. This is nothing but Dalton's law. It is there. Keeping this in the mind, now I go for this. It is PA, ith component. Mole fraction of ith component. Mole fraction of ith component means I'll go for the YA. Very careful. Raoults law for solutions. Dalton's law for gases. YA is nothing but mole fraction of component A in vapor phase. Very, very careful. YA into PT. This is nothing but PT. Can I write?
Yes, sir.
Yes. So what is the formula written beside Dalton's law?
PI, partial pressure of ith component is equal to number of moles of ith component and T, total number of moles, into PT, total pressure. And Dalton's law is applicable for gases. Raoults law applicable for solutions.
Done, sir.
Now, deliberately I'm writing this only because you can see its continuation. Now I'll go for from 1 and 3. It is for the PA, it is for also for the PA. So from 1 and 3, can I say P naught AXA is equal to YA into PT? Can I say?
Yes, sir.
So can I say YA is nothing but is equal to P naught XA by PT? Can I say?
Yes, sir.
So can I write this is YA is nothing but PA by PT? Can I write? Because P naught
Yes,
XA is nothing but PA, correct? Can I write?
Yes, sir.
Yes, sir.
Or can I write in this way, YA is equal to P naught XA divided by P naught XA plus P naught XB. Check earlier, 5 minutes back, I have given to you. What is PT? PT is a total vapor pressure. Check, I have given to you. PT is a P naught XA plus P naught XB. Can I write?
Yes, sir.
Yes. And then similarly, from 2 and 4, so can I say it is a P naught PXB is equal to YB into PT? So I can write here YB is equal to P naught BXB, it is PT, or YB is equal to PB by PT, or YB is equal to P naught BXB divided by P naught XA plus P naught XB. And our main aim is what? Our main aim is a YA. Our main aim is a YB. What was the main side heading? Calculation of composition in vapor phase. And this composition we are calculating not in terms of number of moles. We are not calculating in terms of weight. We are calculating in terms of mole fraction. So YA is the mole fraction of component A in vapor phase. YB is the mole fraction of component B in vapor phase. Make it. So this is the information required.
Done.
And these informations, they won't give in the NCERT book or straight away or directly, they won't give in the Akash book. So these informations only teachers can give you for understanding. And therefore, always I'll say that first you read the book in front of you. Reading Akash book, read Akash book only properly, problem is not there. Then you will get the idea, hey, correct na, this topic is not given the Akash book na, this sir is giving, and then you can copy it properly.
Done, sir.
Good. Now, this part I will rub it. Shall I?
Yes.
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 Now we'll go for the comparison between the ideal solution and the non-ideal solution. So right side heading, comparison between the ideal solution and non-ideal solution, and you have to write in this way. Suppose, take example, if this is a notebook, it is there. If this is a notebook, it is there. Rather than writing in this way, you will write in this way. I'll give you comparison. But don't write in this way, write in this form. Comparison between ideal and non-ideal solutions. They have given whatever the point I'm going to give you. They have given in the Akash book also. They have given in the NCERT book also. But in the Akash book and the NCERT book, same point they have given in the paragraph way. I'll give in the column wise, number wise. Remembering by the column wise and number wise is very easy in comparison to remembering in terms of paragraph. In comparison to remembering in terms of paragraph. So right side heading, comparison between ideal and non-ideal solutions. Ideal and non-ideal solutions. Then you will write here ideal solutions. And then here you will write non-ideal solutions. And you will make three equal partitions. You will make three equal partitions. One partition is an ideal, two partitions equally for the non-ideal, three equal partitions. And here you will write non-ideal, positive deviation, and here you will go for non-ideal, negative deviation. So three equal partitions should be made. Non-ideal solutions, positive deviation, non-ideal solution, negative deviation. Sir, what is the meaning of positive deviation? Positive deviation from Raoults law. It is nothing but what positive deviation on absolute word. It is a positive deviation from Raoults law. If you are so specific, from Raoults law, RAOULTS, from Raoults law. It is a negative deviation from Raoults law. From Raoults law. It is not absolute word positive and the negative. Deviation from which? Deviation from whom? Deviation from studies, a deviation from goal. So here is not studies, deviation from Raoults law and deviation from Raoults law. So once column has been ready, let me know. Okay, Beta. Now coming for the ideal solutions. Ideal solutions. So right, and this is an 2 marks IP question. This is a 2 marks IP question. So suppose take example, how IP question, it is just like comparison in the first year. In the first year you have read, or maybe in the first year chemistry, or maybe in the first year physics also. What are ideal gases? The gases which obeys ideal gas equation, the gases which obeys ideal gas equation, or PV is equal to nRT equation, or PV is equal to 1 by 3 MnC square equation, they are called as a ideal gases. So exactly same type. What are ideal solutions? The solutions which obeys Raoult's law are called as a ideal solutions. The solutions which obeys Raoult's law, if you remember, half an hour back or the 45 minutes back, I have given to you, Raoult's law is applicable only for ideal solutions. Given to you somewhere,
Yes.
Yes.
Yes, sir.
limitations of the Raoult's law. In limitations of the Raoult's law, I have given to you, first point, it is applicable only for dilute solution. Second point, I have given to you, it is applicable only for ideal solutions. And then I have given to you that hashtag that ideal solutions and dilute solutions both are what? One and same, it is there. So this first point is a star mark. It is a 2 marks IP question. It is there. If you will write IP examination, then it is important question. 10th class was Janaganamana. Intermediate first year Janaganamana. If Corona third phase will be there, your second year examination also Janaganamana will be there. That is the condition. Now, just tell me fairly, you all are my kids. I am your teacher. Tell me, what is your opinion? Cancellation of the examination is good or not good?
Both, sir.
Good, sir, because we can concentrate more on it.
No, beta. I don't know why you are saying it is good. Cancel.
But it's not good, sir.
Never good. Cancellation of examination is never good, because if your IP examination would have been there in the month of the April or the month of the March, whatever earlier government thought in the month of the April, if the examination would have been there, you would have been liked or not liked. You would have been forcefully read botany, zoology, physics, and chemistry. Forcefully means forcefully. Correct? When you are
Yes.
reading, liking or not liking, reading forcefully, you are revising first year actually. Actually, when you are writing the examination, you are revising indirectly. Second point, it is that whenever you will go to the examination center, always you will have a fear. Always you will have a fear. Whenever you will go to the new place or the new place, you'll have a fear how the person will behave, how the person looks like, correct? So always you'll have a fear, exam, exam, exam. But when you will attempt your examination intermediate IP, this is only intermediate examination. This is nothing but it will remove your examination fear. Why? Because before your NEET examination is a big battle. Before your big battle, number of small battles you have done fighting. So now you are war veteran. War veteran. So when you are war veteran and now going in the final battle, you can't die. You can't die. But if straight away you are going in the final battle, maybe because of the bad luck, or maybe because your preparation is not proper, maybe someone will cut you. So whatever this local examinations are there or the IP examinations are there, from your mind and the heart, they will remove the examination fear. Oh my God, examination. And when you go to the examination center, although you are well prepared, well prepared, but once you go to the examination center, when the students will talk, you will feel, Arey, they are talking something new. This I have not prepared. This I have not prepared. This is called examination tension. And this tension is required. Yes, this examination tension is required. It is required. Because when you will hear what others are talking, then only you will prepare in a proper way. Otherwise, frog in a well, you will think everything is good. But life is not good. Life is not straight. When life is not so straight, it is there. Life is not so straight, it is there. Then definitely means definitely you have to learn all the things. I am talking to you in general, and in the meanwhile, 3 rogue girls rogue girls, I'll say. Rogue girls have left just now. God knows why they have left. Why they have left. Now coming for the point number one. Right, point number one. The solutions which obeys Raoult's law. The solutions which obeys Raoult's law. The solutions which obeys Raoult's law at all concentrations. The solutions which obeys Raoult's law at all concentrations. Which obeys Raoult's law at all concentrations and all temperatures. The solution which obeys Raoult's law at all concentrations and all temperatures are called ideal solutions. Are called ideal solutions. Are called ideal solutions. Point number one here, and this is common for both. This point is common for both. So write in a straight line. Write in a straight line, common for this also, common for this also. Point number one. The solution which does not obey Raoult's law. The solutions which does not obey Raoult's law. The solutions which does not obey Raoult's law. Which does not obey Raoult's law are called non-ideal solutions. Are called non-ideal solutions. Are called non-ideal solutions. Non-ideal solutions. Non-ideal solutions. Point number two. Point number two. Delta H solution. Delta H solution, or better say, delta H mixing. Mixing will be proper. Delta H mixing is equal to 0. Delta H mixing is equal to 0. 0 means neither heat is liberated nor heat is absorbed. Neither heat is liberated nor heat is absorbed. Nor heat is absorbed. And very easy for understanding. Here positive is there, na? Here negative it is there. Na? So here straight away delta H mixing is a positive. So positive deviation means delta H mixing is a positive. Positive means it is endothermic. Endothermic. As it is a negative deviation, very easy to remember. Delta H mixing will be negative. Will be negative. Here no positive is there, no negative is there. Therefore, it is what? 0 it is there. And you know very well, negative means it is nothing but exothermic. Exothermic. Now coming for number 3. Delta V mixing is equal to 0. Same thing. Delta V mixing is equal to positive. Delta V mixing is equal to negative. Delta V mixing is equal to negative. And this complete table is full of examination questions. So in the table, I'll give you some 9 or 10 points I'll give to you. If that 9 or 10 points you are remembering, then nothing but it is a backbone. It is a backbone of the topic, vapor pressure and the Raoult's law, it is there. Delta V mixing 0, delta V mixing positive, delta V mixing negative. Let us now go on understanding it means what. It means what it is there. Let us assume you have taken 2 beakers. One beaker is consisting of 10 ml of solution A. Another one is consisting of 10 ml of solution B. Both this 10 ml and the 10 ml you are mixing. When 10 ml and 10 ml you are mixing, what you are expecting to get?
20 ml.
20 ml.
20 ml.
Volume.
20 ml. Yes, 20 ml. Volume I'm talking regarding. 20 ml. This is first condition. This is first condition. Delta V mixing is equal to 0. Whatever you are expecting, getting same thing. You are expecting 20, you are getting 20 only. That is the meaning of delta V mixing is a what? 0. 10 and 10, 20 you are taking. 10 and 10 you are taking and you are mixing. and you're observing that after mixing, volume is not 20, volume is 25. Volume is 25. So volume is more than required, less than required.
More than required.
Or required was 20, but it is 25. More than required means it is a plus sign, and therefore in second condition I mentioned to you, delta V mixing is a what? Positive. Positive means
Positive.
we are getting more volume than we expected. And here we are getting in the first case, whatever the volume we thought, exactly getting same volume. Now coming for third condition. In third condition, mixing 10 and 10, and we are expecting the volume to be 20, but we are getting volume 10, maybe 12, maybe 5, expected 20, but getting value less than 20, less than expected. And that is the reason why here sign convention is a what? Negative, it is there. Anyone doubt on that point?
No, sir.
No, sir.
So rest I'll give you tomorrow. Tomorrow I'll complete this topic. Tomorrow means this table I'll complete it. This is there in the NCERT book also, Akash book also. You all are having the Akash book. Definitely read from the Akash book so that once I am giving you tomorrow explanation, you will understand in the proper way. Understanding in the proper way is very much required to get good marks in the what? Examinations. Let us meet tomorrow at same time. See you. Thank you.
Thank you,
Thank
sir.
you,
Bye,
sir.
sir.
Sir,
Yes.
Thank you.
sir, bye, sir.
Thank you, beta. Bye-bye. Thank you.